Welcome to Regression Tutorial 3, Validating the Model. In this tutorial, we will validate the model we developed in the previous tutorials for our wine price estimation example. In our previous tutorial, we had developed a model to predict the prices of a bottle of wine depending on 4 independent variables: the points by Robert Parker, the age of the vineyard, recent vineyard awards, and whether or not the wine was from Burgundy. We had verified that the p-values were acceptable, they were outstanding for points, for age of vineyard, and for recent vineyard awards, and we had some hesitation about including Burgundy in the model because its p-value is barely significant at the 90% confidence level. In this tutorial we will further validate the model. In particular, we will look at some of the additional output that Excel provides. To do this, we once more run a regression, but this time we make sure that we select under Output Residual Plots and the normal probability plot. The output here is a little messy, so let's start looking at one plot after the other, and for that it's worthwhile to enlarge each of the plots a bit so that we can have a better look at it. Here you see the normal probability plot. Again, what we are trying to test is the assumption that the errors are normally distributed, and if the plot goes from lower left to upper right, this is the case. So once again, here the normal assumption seems to be justified. So let's have a look at the next plot. Well, the next plot is the residual plot for the dummy variable Burgundy. Usually there is not much in a dummy variable residual plot. We see on the left side the residuals for all wines that are not Burgundies, on the right side for the Burgundies. Yes, the error for the non-Burgundies is somewhat larger, but we simply have more data points there, so this is usually not a particularly interesting plot. So let's have a look at the next plot. The next plot is the residual plot for the recent vineyard awards. Here we don't see much of a pattern in the errors. They're not becoming larger, they're not becoming smaller from left to right, so no sign of heteroscedasticity with respect to the vineyard awards. The residual plot for the age of vineyard doesn't look as good as the previous ones. Here we clearly have a tendency, in particular for younger vineyards, we tend to have negative residuals, and for older vineyards we tend to have positive residuals. Basically what this means is that for younger vineyards we tend to underestimate the price of wine, and for older vineyards overestimate it. This is something we may want to consider later if we should make some changes. We could perhaps transform the age of the vineyard, we could transform the price, but before we do that, let's have a look at the final residual plot. The final residual plot, the residual plot for the points, looks great. No signs of heteroscedasticity whatsoever, so here we are fairly safe. This leaves the question what to do with the vineyard age. Well, as it turned out, I tried several transformations of both the price variable as well as of the vineyard age variable, and the best I could find was taking the logarithm of the vineyard age. The resulting regression has actually a slightly better R-squared than our original regression. Also, Burgundy is now almost at the 95% confidence level, its p-value, so perhaps we have indeed a better regression, Unfortunately, the residual plot for the vineyard age is still not perfect, however it is better than before. There is still some tendency to overestimate very old vineyards, but not as much as before. By and large, I would be content with this regression. I may still play around with some other variables now that I have changed the vineyard age to logarithm of vineyard age, but in the end, at some point one has to come to a conclusion. So what I would do is would test this regression, how well it does in predicting our test data, and also the previous regression where we had the vineyard age, and see how well that comparatively does in predicting our test data. In the end then, I would take the better of those two. This I will do in the next and final tutorial.